Alright, so for number 7, again, the number in pink is the one I added in because since I had 3i, I need its conjugate. And so now I'm going to set up the polynomial in factored form. So the factor for 1 would be x minus 1. The factor for negative 1 would be x plus 1 cubed because its multiplicity is 3. The factor for 3i would be x minus 3i. And the factor for negative 3i would be x plus 3i. Okay, so let me write this out because, again, you're going to have trouble if you keep it like that. So I'm going to write it out 3 times. So x minus 1 comes down, x plus 1, x plus 1, and x plus 1. And let me just write down the other 2. Okay. So I'm going to pair them up. Okay, so I'll do these, then I'll do these, and then I'll do these. Okay. So from the first, the green one, it's going to be x squared plus x minus 1. For the second pair, it's going to be x squared plus x plus 1. And for the other one, it's going to be x squared plus 3ix minus 3ix minus 9i squared. Okay, so now we're going to simplify. So right here, the x minus x, that's gone. So you're left with x squared minus 1. Right here, it's x squared plus 2x plus 1. And over here, this is gone. And remember, this I squared is negative 1. So negative 1 times negative 9 is positive 9. Okay? So now notice I have 2 binomials and a trinomial to multiply together. So again, I think it's a little bit easier if less work at the end, if you just multiply the 2 binomials first. So we'll do that. So that's going to give me x to the 4th plus 9x squared minus x squared minus 9. I'm just using distributive property. And then we'll bring down the other one. Okay? So I can combine these 2 together. So that's going to give me x to the 4th plus 8x squared minus 9. And this one's x squared plus 2x plus 1. So I've got a 3 by 3. So what I'm going to do with this, I'm going to make a grid because I think it's a lot neater. And you won't miss any terms if you draw a grid because that means that you have to have a term in every square. So x to the 4th, 8x squared minus 9. And then over here, x squared, 2x, and 1. And we're multiplying together. So I've got x to the 6th, and then 2x to the 5th, and then x to the 4th. Next row, 8x to the 4th, 16x to the 3rd, and 8x squared. The third row, negative 9x squared, negative 18x minus 9. So I'm going to see if I have any like terms. I've got 2x to the 4th. I've got 2x squares. And that's it, right? All the other ones are there just once. So the polynomial will be x to the 6th plus 2x to the 5th. 8 and 1, x to the 4th gives me 9. Cubic, there's just 1, 16x cubed. Squares, there's 8 minus 9, that gives me negative. Then minus 18x, oops, it's barely going to fit, minus 9. So right here, that's the polynomial. Alright, so 3 with a multiplicity of 2, 3i, and I added the negative 3i because it was not given to you. So the factor for 3 would be x minus 3 and it's squared. The factor for 3i would be x minus 3i, and the factor for negative 3i would be x plus 3i. So I'm going to write out the square one. I'm going to write it out like this. It's better to be safe and write it out than to think you know how to square it and make a mistake. And let me just bring down these right here so that they're on the same line. So this pair and this pair. Okay, so let's see, x squared minus 3x plus 9. And then over here, x squared plus 3ix, and again, I'm just doing distributive property, minus 9i squared. Okay, combine like terms, so that gives me x squared, these two together is negative 6x, and then this cancels, so you're left with x squared. Now, I squared is negative 1, so negative 9 times negative 1 is plus 9. So now I got a 2 by 3. You can do the grid. Get a 2 by 3. And x squared and 9 go here. X squared minus 6x and 9 go here. We're multiplying. So this is x to the 4th minus 6x cubed. 9x squared. 9x squared minus 54x and 81. So the only pair of like terms are these two right here. Okay, and so now we rewrite our final answer. F of x is x to the 4th minus 6x cubed plus 18x squared, because that's 9 and 9, minus 54x plus 81. And there's the polynomial right there. Alright, so for 12 you have to factor a and b and then list the letters, these right here, that you know, for the zeros for each polynomial. Let me start with b, just because it's a shorter one, and I recognize that I can treat this as a quadratic because here this is twice as big as that power, and I've got 3 terms, and I know that factors of 4 that add up to 5 are negative 1 times negative 4, so it works out nicely like that. So this means that I could factor this as x squared minus 1 and x squared minus 4 equals 0. So this is a difference of squares, and this is a difference of squares. So this is x plus 1, x minus 1, x plus 2, x minus 2. So my zeros are plus and minus 1, so a and d. Oops, put it on the wrong spot, sorry. A and d, plus or minus 2, b and c. Okay, so that's the answer for part B. For equation A, okay, I'm going to have to do the p's and q's, so let's see. For 8, it's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. For Q, it's going to be plus or minus 1. So P over Q gives you the same list right here. So I'm just going to go base it off of that. So I'm going to do synthetic division. So 1, 2, 4, negative 8. 1, 2, 4, 8, and that works. Okay, it worked once. I'm going to see now the leading coefficients right here are all positive. You see that? All positive. So I'm not going to use positive zeros anymore, because my goal is to get another 0, right? But if all of these are positives and I use another positive, there's no way it's going to give me a 0. So I need to switch over to negatives. So I'll start off with negative 1. And remember, use the reduced polynomial. Don't use the original. So 1, negative 1, 1, negative 1, 3, and doesn't work, right? This gives me 5. Okay, I'll go over to negative 2. Negative 2 gives you 1, 2, 4, 8. Bring down the 1. Negative 2 is 0. This is 0, 4, negative 8, and this one worked. Okay? The quadratic that's left is x squared plus 4, and we've solved that one several times. Right? We've solved it several times, so this gives me that x equals plus or minus 2i, because you get square root of negative 4. So you get plus or minus 2i. So the zeros are 1, so for part A, it's A, and negative 2, so that's B, and then plus or minus 2i, so that's E and F. And there's the answer. Alright, so the problem is asking you what's the least degree of a polynomial that has these zeros, or these roots. So if 3i is a 0 with a multiplicity of 3, that means that negative 3i has to be a 0 with a multiplicity of 3 also, because every 3i has to have a partner. Now, 2 minus radical 3 is an irrational 0, and those also need conjugate pairs. So that means I have to include 2 plus radical 3 with a multiplicity of 2 to match. Each one has to have its partner 2. Well, let's add up the multiplicities. I've got 3, 3, 2, and 2. So that's a total of 10. So the least degree for this polynomial, the least degree is 10.